Welcome back to the second video where we're going to do some examples of combining sine and cos functions into a single sine function. In this example, we're going to do a slightly more complicated example in that we need to be careful about finding the shift, but we'll see that as we go along. So here we want to try and combine, this is example 2, we want to write minus sine of 2t plus cos of 2t. We want to write that as something times sine of 2t plus alpha. So this is slightly different than the past question in that instead of dealing with sine of t, cos of t, and writing it as sine of t plus alpha, we've got a 2t in here. So the important thing to note that we can change this formula by just replacing t by 2t everywhere, and the formula is just as valid. So we can still use the same principle, and we can combine a sine of 2t and a cos of 2t as a sine of 2t plus alpha. So it's worthwhile noting that we can combine two cos and sine functions, but the important thing is that these things, the periods, have to agree. If these don't agree, we can't combine them using this method. So for example, if this was cos of t on its own, we can't combine them using this method. You can combine them, but you might need to use a different method for that. And it's also important to note that if these, whatever this is, sine of 3t or 5t or whatever, that, this and this all have to agree. Apart from that, the method is pretty much the same. So in this case here, step 1, as usual, is to find the amplitude. And we do this by saying that a is equal to the square root of a squared plus b squared. So our a here is the thing in front of the sine, which is minus 1. Our b here is the thing in front of the cos, which in this case is 1. So our a is equal to the square root of minus 1 squared plus 1 squared is equal to the square root of 2. So we've found the amplitude of our new combined function. So now we need to go on and try and find out what the shift is, what alpha is. We know that sine of alpha is the thing in front of the cos, our b, divided by a, and we know that cos of alpha is the thing in front of the sine, or a, divided by the amplitude. So in this case here, sine of alpha is equal to the thing in front of the cos, which is 1, divided by the amplitude. Cos of alpha is the thing in front of the sine, which is minus 1, divided by the amplitude. So this is different than our first example in that the sine here is positive, whereas the cos is negative. Now it's really important to use the sign, SIGN, of both the sine and the cos to determine what quadrant alpha's in. It's easy to skip this step and get the wrong answer. So step 2 is to find the quadrant for alpha. And I'd like you to do this as a separate step before going straight into trying to find alpha. So using our usual all stations to central mnemonic, or whatever mnemonic you want to use, we know that sine is positive, cos is negative. In the second quadrant, sine is positive, all the others are negative. So this alpha is in the second quadrant somewhere. We're using the sines of both to determine where alpha is. So this is our alpha. we know that it's in the second quadrant. And we can use the signs of each one of these in different combinations to get all 4 of the different quadrants. Okay, so step 3 is to find theta, which corresponds to alpha, except it's in the first quadrant. So if the angle's in the first quadrant, both sine and cos are both positive up here. So we know that sine of theta, if it was in the first quadrant, is 1 on root 2. Cos of theta in the first quadrant is going to be plus 1 on root 2. And then we can find theta. In the first quadrant, we use the triangle with just 1 along here, 1 up here, root 2 down here, and this will be 45 degrees or pi on 4. So we know that for sine and cos positive, theta is equal to pi on 4. So step 4 is then to find alpha. We know that alpha's in the second quadrant. We know that if it was in the first quadrant, it would be pi on 4. This is our theta here. If it was in the first quadrant, it would be here. So to find alpha, this angle here will be this angle minus theta. So we have that alpha will equal all of this, which is pi, minus this angle, theta. So for the second quadrant, this is the formula that you use here. This is pi minus, and we found out that theta was pi on 4. So we've got 4 pi on 4 minus 1 pi on 4 is 3 pi on 4. So let's just summarise these steps again. We found the amplitude. We used the amplitude to find sine and cos of alpha. We can then use the sine of these to find out what quadrant alpha's in. Then we can find, now in this case here, this is not in the first quadrant, it's a little more complicated. Because it's in the second quadrant, we can then find theta if the angle was in the first quadrant, and that angle up here will be the same as this angle. And so we can use this theta to find alpha. Going through that again, this angle will be this angle minus theta. So we get that alpha is equal to pi minus pi on 4, which is 3 pi on 4. The last step, step 5, always remember to write out the answer, is to write the answer. This is quite important, apart from anything, if you're writing a report or if you're in an exam, if this is what they're after, if we're after this form, we should write it out. Don't leave it in pieces all over the page. So in this case here, we've found out that the amplitude is root 2. It's sine. The period, well, the period is pi, or we've got 2t in the argument, and our shift is 3 pi on 4. So let's just revise so that you know what to do for all of the different combinations. I'll do this in a different colour. If sine was negative and cos was positive, we would be down here. And in this case here, this is the angle that we're after. So in this case, in the red case, if it's in the third quadrant, our alpha is equal to negative what it would be in the first quadrant. Last combination is that if sine was negative and cos was negative, then tan would be positive, cos and sine are both negative, so we'd be down here in the third quadrant. So in this case, we would find out what the angle would be in the first quadrant. That would be this angle. And to find out this angle, alpha will equal minus 180 degrees plus theta. So writing this here, we've got that alpha is going to be this angle minus pi plus what it would be in the first quadrant. So for each one of the different combinations, you can find out alpha. I think the easiest way to do this, at least at the beginning, is to find the sines of sine and cos and decide what quadrant the angle is going to be in. Find out what quadrant it would be in, find out the angle if it was in the first quadrant and adjust for alpha after that. Just a note, some methods ask you to find sine alpha on cos alpha and just use tan of alpha. The problem with that is that we lose the signs, the SIGN of both sine and cos, and on average, half of the time it will give you the wrong question. So it's important, even if you want to use the tan alpha method or the tan method, it's really important to keep in mind which quadrant we're talking about all along. For example, if I found out that if I found tan was positive, let's say for the green case, if I got that sine was negative and cos was negative, we know in that case the angle will be in the third quadrant down here because sine and cos are negative. But if I just put tan alpha is equal to what it's going to be, 1 in that case. If I put tan alpha equals 1 into the calculator, it'll give me an answer in the first quadrant. It'll assume that the angle's in the first quadrant. So we need to be careful. We need to use all of the information along the way. But at least now you hopefully have an algorithm for finding alpha in whatever quadrant it ends up being in. And let's just recap. The reason why we're doing this is that one of the reasons is that this is very much easier to plot than these two functions separately. And not only that, if you've got a plot that this thing is equal to a number, let's say a half, it's easier to solve that this thing's equal to a half than it is to solve that addition of those two things are equal to a half. In the third video, we're going to give you a bit of an idea of where the theory comes from, where these different formula come from. So if you're interested in finding out about those, hang around for that last video. Thank you.